Welcome to all of you. Today we discuss on MCQ of the paper CC1 Mathematics Honors, University of Calcutta, year 2018. First question is the curve y equal to e to the power 2x is convex with respect to y-axis, convex with respect to the x-axis, concave with respect to the y-axis, concave with respect to the x-axis. Correct option is 2, convex with respect to the x-axis. Because if we draw y equal to e to the power 2x, then we get this is the curve. Obviously, this curve is convex with respect to the x-axis. First we find dy dx, that is y dash, and d2y dx squared, that is y double dash, and the formula y into y double dash, this is equal to 4 e to the power 4x, which is greater than 0 for any x, real x. So the given curve is convex with respect to the x-axis. Next question, 1b, asymptote of the curve y equal to x plus sin x is this. Here correct option is 4, does not exist. Here clearly limit x tends to infinity y, that is x plus sin x, is tends to infinity. So there is no horizontal or vertical asymptote. And to determine the oblique asymptote, y equal to mx plus c of the curve, given curve y equal to x plus sin x, we find m, which is equal to limit mod x tends to infinity y by x, and value of y is x plus sin x. So this is equal to 1 plus sin x by x, and sin x by x limit x tends to infinity is 0 because of the squeeze theorem, and this is equal to 1. So m value of m equal to 1. And the constant c is given by limit mod x tends to infinity y minus mx. Here m is 1, so y minus x, and from the given curve y equal to x plus sin x, so y minus x is equal to sin x. So limit mod x tends to infinity sin x, which does not exist. So the correct option is 4. The asymptote of the curve y equal to x plus sin x does not exist. By the Desmos graph, y equal to x plus sin x, and this graph of the curve is this type. Clearly from this graph, there is no horizontal or vertical asymptote or oblique asymptote for this curve. Next, a necessary condition for the existence of the limit x tends to 0, a sin 2x minus b sin x by x cube is, correct option is 4, 2a equal to b. Clearly, this given limit x tends to 0, a sin 2x minus b sin x by x cube is 0 by 0 form. So we can apply L'Hospital rule. So difference with respect to x, numerator and denominator, 2a cos 2x minus b cos x divided by 3x square. And this limit is finite. Since this limit is finite, so numerator must be 0 and denominator must be 0, because denominator is 0, so numerator must be 0. So at the point x equal to 0. So a numerator value at the point x equal to 0, 2a cos 0 plus b cos 0 equal to 0, so 2a equal to b. Correct option is 4. Next question, the area of the region bounded by x equal to plus minus 1, y equal to 0, and y equal to x square. Correct option is 2 by 3 square unit. And here the curve y equal to x square, and this line, vertical line, x equal to 1, and this is the vertical line, x equal to minus 1, and this is the x-axis, y equal to 0. So bounded by this region, shaded region. So first we find integration x tends to x equal to 0 to 1 y dx is the area of the first quadrant, multiplied by 2 is the required region. So clearly this is 2 by 3 square unit. Correct option is 2. Next, unit 2. Question number 3a. The polar equation 12 minus 4a plus root 2r cos theta equal to 0 represents an ellipse. 12 minus 4r plus root 2r cos theta equal to 0. First we write this equation as 12 by r equal to 4 minus root 2 cos theta, and dividing on both sides by 4. So 3 by r equal to 1 minus 1 by 2 root 2 cos theta, and comparing with the standard form L by r equal to 1 minus e cos theta. Is the standard form of the conic, L is the semilatus rectum, and E is the eccentricity of this conic. So we get E equal to 1 by 2 root 2, which is less than 1. Clearly, it is an ellipse. R equal to 12 by, if we draw this, R equal to 12 by 4 root 2 cos theta. 4 minus root 2, root 2 cos theta. So this is the polar equation of this graph, and this curve is obviously an ellipse. So E is less than 1, so this is ellipse. Next question 3b. Question 3b, the center of the circle x square plus y square plus z square minus 2y minus 4z equal to 11, and cuts by the plane x plus 2y plus 2z equal to 15, each at, correct option is 1, 1, 3, 4. First equation is the sphere, and second equation is plane, and the circle is given by the sphere and plane. And we know for the standard form, for standard equation of the sphere, x square plus y square plus z square twice ux plus twice vy plus twice wz plus d equal to 0. Center is minus u minus b minus w. Radius is root over u square plus v square plus w square minus d. And comparing with the given equation of the sphere, x square plus y square plus z square minus 2y minus 4z equal to 11, we get u equal to 0, v equal to minus 1, w equal to minus 2. And the center of the sphere is 0, 1, 2. And the radius is given by 4 units. So this is the figure. This is the figure is sphere, and center of the sphere C is 0, 1, 2, and rho CP is the radius of the sphere, 4 units, and the plane, this is the plane, cuts the sphere, so we get a circle. And so draw a perpendicular from C to the plane, which is N, and the distance of the plane from the C is Cn, and is this ax1 plus by1 plus cz1 plus d whole root over a square plus b square plus c square modulus is equal to 9 by 3. This is equal to 3 unit. So Cn is 3 units. This is the distance of the center of the sphere to the plane. Now NP is given by Pythagoras theorem, and this is the right angle triangle CNP. N is the right angle, CNP is the right angle. So NP equal to root over of CP square minus CN square, and is the root over 7 unit. So this is the radius of the circle is np, which is given by root over 7 units. And equation of the line Cn, this line is passes through the point 0, 1, 2. So x minus 0, y minus 1, z minus 2. And the direction ratios of this line Cn is 1, 2, 2, because this line is perpendicular to the plane, given plane. So the normal to the given plane direction ratio of the normal to the given plane is 1, 2, 2. So this is the direction ratio of the line Cn. So equation of the line Cn is this, equal to r, non-zero quantity, say. So any point on this line can be written in the parametric form r, comma 2r plus 1, comma 2r plus 2. And since this point uh, lies on the plane, so this point satisfies the plane, equation of the plane, and from this, putting the value of x, y, z in the plane, we get the value of r equal to 1. Hence, the value of this x, y, z, putting r equal to 1, we get the point 1, 3, 4, which is the center of the circle in circle in point in is the center of the circle. So correct option is 1. And next question, unit 3, question number 5a. The angle between the planes r dot this equal to 7 and r dot this equal to 5 is the correct option is 2, cos inverse 5 by root over 14 root over 38. We know if there are two planes r dot in one vector, r vector dot in one vector equal to q1 and r vector dot into vector equal to q2, the angle between them theta is given by cos inverse cos inverse in1 vector dot into vector whole divided by modulus of n1 into modulus of n2 vector. Here n1 is this 2 I cap 3j cap k cap, and q1 is 7, and n2 vector is this, and q2 is 5. So after simplification, you get theta equal to cos inverse 5 by root 14 into root 38. Next question, the distance of the point 1, 2, 3 from the plane r dot this vector equal to -1. Correct option is 2, 1 by root 26 unit. And this we know the perpendicular distance from a point A vector of a point A vector from the plane r vector dot n vector equal to q is q minus a dot n divided by modulus of n vector. And distance will be considered as positive or negative according as the point A vector will lie on the same or opposite sides of the plane as regards origin. Here a vector is this 1, 2, 3, and n vector is this 3, -4, 1. N vector is this, n vector is this 3 I cap -4 j cap plus k cap, so 3, -4, 1, and q equal to -1. So by formula q minus a dot n vector whole divided by modulus of n, and we get the 1 by root 26 units. Next question, if r vector is differentiable vector function of a scalar variable t such that r vector equal to this when t equal to 2 and r vector equal to this vector when t equal to 3, then find the value of integration 2 to 3 r dot dr vector dt whole dt is this of correct option is 10. 1. We know ddt of r square is equal to twice r vector dot dr vector dt, because r vector means r square means r vector dot r vector. So ddt of r vector dot r vector equal to 2r vector dot dr dt. So d of r square is equal to 2r vector dot dr vector dt whole into dt. So integrating we get r square plus c is equal to integration 2r vector dot dr dt into whole into dt. C is the integrating constant. So limit 2 to 3 integration 2 r vector dot dr dt is equal to r square limit t equal to 2 to 3. So FB minus FA, so r square at the point 3 minus r square at the point 2. So r square means r dot r vector at the point t equal to 3 minus r dot r vector at the point t equal to 2. Now r vector at the point t equal to 3 is given by this 4 I cap minus 2 j cap plus 3 cap. And so this 4 I cap minus 2 j cap plus 3 k cap dot 4 I cap minus 2 j cap 3 k cap minus r vector at the point 2 is this 2 I cap minus j cap plus 2 k cap dot 2 I cap minus j cap 3 cap. And after simplification, we get 20. But here 2 multiplied by 2, so divide by 2, we get the correct answer is 20 by 2 is 10. Correct option is 1. And last question, if r vector is this sin t I cap cos t j cap 2 t k cap, then the value of the modulus of d2 r vector dt square is this. Correct option is 1, which is 1. Here r vector is this, so velocity vector dr vector dt, this v vector is this, integrating with respect to t, and the acceleration vector d2 r square dt square is this. So modulus of d2 r square dt square is this minus sin t whole square plus minus cos t whole square, which is equal to 1. The correct option is 1. Thank you.